Now let's just further talk about the concept of the relationship between the zeros and the coefficients of a polynomial, but of a special type of polynomial, which is a cubic polynomial. Now in the same way like we did for the quadratic polynomial, we will find the relationship between the zeros and the coefficients of a cubic polynomial. So let's just consider any particular example. So let us suppose we have this cubic polynomial p of x as 2x cube minus 5x square minus 14x plus of 8. First of all, we have to find out the zeros of this particular cubic polynomial. So using the factor theorem, or we can say the hit and trial method, we can able to find out the number of zeros or the zeros of this particular cubic polynomial. So let us suppose I am taking the very first value as x is equal to minus of 2, and I am actually verifying that whether x is equal to minus 2 is nothing but the zeros of this particular polynomial or not. So let's just substitute x is equal to minus of 2 into this polynomial. So it is p of minus of 2, which is 2 into minus 2 cube minus of 5 minus of 2 whole square minus of 14 minus of 2 plus of 8. Now let's just solve it. So it is p minus of 2, which is 2 minus of 8 minus 5 into 4 minus is plus 28 plus of 8. Further we can say p of minus 2 is equal to minus 16 minus 20 plus 28 plus 8 is nothing but 36, and further minus 36 plus 36 is nothing but is equal to 0. It means that p minus 2 is equal to 0 implies minus 2 is nothing but the 0 of this particular cubic polynomial. So if minus 2 is the 0 of the cubic polynomial, so using the factor theorem, we do know that x plus 2 is the linear polynomial that can divide this particular cubic polynomial, and using the factor theorem we can divide both of these and we can able to find out the other factors as well. So let us suppose I am writing all the zeros of this particular cubic polynomial as the zeros of the polynomial p of x of the polynomial px are, first of all it is minus of 2, 4 and half. So 4 and half are the further number of zeros of this particular cubic polynomial. You can also check it by substituting the value 4 and half in this particular cubic polynomial, and at the end you will get the value as nothing but is equal to 0. It definitely means that 4 and half is nothing but the zeros of this cubic polynomial. So we have to find out the relationship in between the zeros and the coefficient. So the three zeros are minus 2, 4 and half. Now let's just check their relationship between the coefficients that is given to us in this particular cubic polynomial. So let us suppose I am expressing this cubic polynomial as nothing but ax cube plus bx square plus of c of x plus of d into the d formation. Let us suppose I am expressing it as this, and further I am taking the sum of these three zeros and the product of these three zeros. So let us suppose I am taking the sum of the zeros. The sum of the zeros is minus 2 plus 4 plus of half. Minus 2 plus of 4 is nothing but 2 plus of half, which is nothing but is equal to 5 by 2. When we will take the LCM, it is nothing but 5 by 2. Let's just take the product of the zeros. The product of the zeros is nothing but minus 2 into 4 into half. 2 and minus of 2 when get cancelled, it is nothing but is equal to minus of 4. It is nothing but minus of 4. Now let's just express it into the formation of the coefficients. Let's just compare the values. By comparison, we can take A as 2, B as minus 5, C as minus 14 and D as nothing but is equal to 8. So the sum of the zeros which we already have concluded, the sum of zeros is nothing but is equal to 5 by 2, and further we can write it as minus 5 divided by 2, and minus of 5 is nothing but the value for the variable b. So it is minus of b, sorry, not a variable, it is a constant. B is a constant, so b is minus of 5, so we can write minus 5 as nothing but b, so it is minus b, and the value of 2 2 or the value 2 is actually is equal to a. So we can write a in place of 2. Hence at the end what we are getting, that the sum of the zeros can be expressed as minus b by a. Let's just talk about the product of the zeros. Let's just talk about the product of the zeros. The product of the zeros is nothing but minus of 4. We can express it into the formation of minus 8 by 2 as well, and this is nothing but minus of 8. Or we can say d is equal to 8. It means we can express it as minus of d divided by a, as a is nothing but is equal to 2. So at the end what we are getting again, we are getting the relationship, the product of the zeros is nothing but minus of d by a. Here we have another relationship as well, that is the sum and product of the zeros taken two at a time. There is an extra relationship in between these zeros, that the sum and the product of the zeros taken 2 at a time. So we have to take the zeros 2 at a time. So let us suppose we have the 3 zeros as minus 2, 4 and half. We are taking 2 at a time. So let us suppose I am starting with minus 2 and 4. So minus 2 into 4, their product, and after the addition with the another product of the two zeros. So 4 into half plus again we can write half into minus of 2. Now let's just solve all these values. As we can see that it is nothing but minus 2 into 4, which is minus 2 into 4 is nothing but minus of 8 plus of 2 into 1, and 2 into 2 is nothing but plus of 2. Further 2 and 2 get cancelled, it is nothing but minus of 1. We can express it as minus of 9 plus of 2, which is nothing but minus of 7. And minus of 7 can be expressed as minus 14 by 2, and this is nothing but minus of 14 is the value c. So we can express it as c by a. So this is nothing but another relationship between the zeros and the coefficient. So first one is minus b by a, which is sum of the zeros, minus d by a is the product of the zeros, and the sum and the product taken 2 at a time is nothing but is equal to c by a. So this is all about the relationship between the zeros and the coefficients of a cubic polynomial. Now let's just discuss it in general.